Welcome to Andy's Rec Room. For all you folks coming back, a huge thank you. For all you new visitors, welcome. If you enjoy this video, please like and subscribe. It helps new channels like my own develop and carry on, so that'd be greatly appreciated. Today, it's the 24 wrap up. So 2024 was quite a good year for me. I made a lot of progress in my projects, and I'm quite pleased to do a wrap up today. It may or may not be the last video of the year, but it's sort of the most consequential because I'll be touching on points I had in other videos. So there'll be a little bit of duplication if you've seen the previous ones, and I apologize for that for the folks that are coming back. But it's kind of relevant to today's video to include everything and show how this whole system progressed. What I'm calling today's video is the audio ecosystem. And you're probably going, oh my God, another freaking pretentious bullshit audiophile video. No, it's not. What ecosystem means to me is an equilibrium of parts, the way they work together and what they provide. Their sum total is greater than each individual component or the perceived value of each individual component. So we're going to start off today with turntables is going to be our first area. Then we're going to go into the speakers, the amplifiers, and then the complete integration of the project. And I'd like to talk a little bit about, the whole turntable and vinyl world, as this project is a bit vinyl centric in its development. The first question you'd probably ask somebody in the field, seeing some of the new developments, is a $300,000 plus turntable worth it? Is it good? Well, that's a two-parter. Is it good? Yes. There's a lot of R&D, and the science behind development of these turntables is very solid, very intricate, very involved. So no beef with that whatsoever. Do we need that kind of technology? My solid answer is absolutely not, and I'll tell you why. Not because it's bad or not good or doesn't work as advertised. It's the equivalent of reading your newspaper with an electron scanning microscope. You're simply hitting a point where the extra resolution isn't giving you any more musicality, any more enjoyment of actual music. So we come back to this whole concept of the audiophile. Now, the word audiophile is just simply lover of sound, basically, and it could be extrapolated to lover of music. In its purest sense, it's something really nice, but it's devolved into something very toxic where it's sort of ego-driven and money-driven. And the reality is, a lot of these systems that cost $50,000, $100,000, $200,000, $1 million aren't really that good. If you go to shows and actually listen analytically, you'll find that some of the products that end up costing about $1,000 to $2,000 for speakers, for example, are incredibly good. Even up to, I'd say, $20,000. There's a range where you're going to get some really, really, really nice speakers. But beyond that point, they start devolving into sort of exercises in design. There's really no value there. So my point is the stuff good? Yes. Do we need it? No. Firm no. It just simply basically you're looking at a point where you're starting to listen for thermal noise from an output, of a mixing console. There's nothing there. The music's, you've hit the music, you've enjoyed the music. Anything past that resolution isn't really enjoying the music. And you got to remember the type of equipment that this was, recorded on. Back in the day, they didn't have a microscope base to hold their equipment to record it. And I'm not joking. Some of these companies are using actual microscope bases for stability for their turntables. And while, again, you can't argue the fact that it's stable, the question is, do you need it? That's the point. So we're getting down to, if you want to enjoy your favorite 1959 Miles Davis kind of blue album, then say you have a original pressing or a really good re-release, you can get there with fairly modest equipment. Honestly, you can get there and enjoy the music, and it's going to be very, very pleasurable. So we're in a world now where audiophile is a self-anointed title. It's ridiculous because we, people in the industry, are here to make the experience of listening to music enjoyable. When I was doing sound design for theater, and thousands of people have seen my work, I got well paid for it. My job was to make it enjoyable for everyone, not an exclusive set of golden-eared people. If you have that approach, it's bordering on nonsensical because we don't all have bat-like hearing, which makes us an audiophile. We can train our hearing to hear details and get better at analyzing. But the ultimate goal is to make this experience, number one, fun and a true pleasure for everybody, not an elitist set of individuals that claim to have this incredible knowledge. I mean, if they did, they wouldn't be, gluing crystals inside their, switches to improve the digital audio quality. Because first of all, at that point, it's not even audio, it's data traveling through these units. And, you get people like worrying about minute vibrations. Well, when we set up the Excel Center in St. Paul, Minnesota, we put in, among other things, 96 Meyer Panther speakers, state of the art. Now these things will just literally, melt your brain how good they are. They're fed from a Luminex switch on the top bumper, which hangs 12 speakers. Now, if you don't think there's vibration traveling up into there, boy, oh boy, you got a surprise coming. And the whole thing is like, do they sound good? Yes, they sound fantastic, and they're loud, and they got detail. And if you're enjoying concerts and you like live music, that's the technology. It's robust, it's excellent. If anybody's into learning more about digital audio, go take the Dante courses. There's level 1, level 2, level 3, and I think there's some supplementary ones they have now. They'll go through all the data you need to understand how, data packets move through, prioritization and so forth. And if you want to get an enterprise level router, you can, and they will prioritize the packet delivery and so forth. But that's for hundreds of tracks of audio, not for stereo. So the data is out there. If you guys are curious, I'll put a link down below for that as well. And then we can, all be on the same page as to what's happening in the digital world and really enjoy what we're doing right now. So that is sort of the concept of this video, which is basically a synopsis of my mindset and what I've built over the year. I'm going to stop right here. I'm going to reset for a second, and then we're going to go through the project as it evolved. Okay, guys, so how did this project commence? And in some of my other videos, I already spoke about it. So like I said, there'll be a bit of doubling up on information. It started off with my revolver and turntable, and I wanted to get the revolver up to a slightly higher level. So what I did was I did a lot of research, and I decided to build a tone arm. The Pickering Unipoise was the initial impetus, the fire to build it, because it's so gosh darn cool looking. And then I came across Stu Nellis and his whole development of literally a ballpoint pen refill as the pivot. And it's quite genius because the tip actually is super well machined and very, very accurate. So the style was given to me by Pickering from the late 50s. Stu gave me the concept for the bearing, and I went, let's build something. So I started off emulating the Unipoise, and I'll have a picture up here. And what happens in the Unipoise is a 2-level system where you have the arm, and then you got another bracket going above the arm for the pivot. Now, I tried one incarnation like that, and as you can see in the photo here, it kind of raised it a bit high, and it was a bit pendulous, to say the least. And I'm sure it would have worked if I had some guides on it like they have in the Unipoise for the actual arm moving against the pivot. I didn't want it. I wanted all free air. So I changed it up. I put the pivot on top, and then the weight came on the bottom. It was built from a self-mandated direction of using stuff I had in the studio. So I had some nice maple I scavenged from an art crawl. It was in a dumpster, and there was a few strips, beautiful wood, nice and hard, quite old. I had some aluminum extrusion for some gimbal projects that I had built many, many years ago. And I had this piece here. And of course I had some transformer wire, which is enameled copper and very flexible, good conductor. So I said, I got pretty much everything I need right here to build a tone arm. So the first baby was this guy right here. So the aluminum basically got divided into 2 parts, one for the tip, one for the counterweight, and it went from there. The tip was epoxied on to give more mass and a bit of a good base for the cartridge, so the vibrations wouldn't be dissipated, and the stylus has something to work against to get a better vibration. And down at the other end, what I did was I made a shape like this for the counterweight. Now, when I was building it, I realized, hey, wait a minute, I shouldn't be gluing this thing. Let's use double-sided tape in a couple sections here and leave a small gap at the back to create a buffer. So it works in 2 ways. One, it prevents a harmonic resonance from vibrations traveling up the tone arm and back and forth. There's just a little damper, like putting your finger on a guitar string. And secondly, the pivot is isolated from the rest of the tone arm because any vibrations coming up this way are slightly nullified by having these dampers here. Of course, huge vibes are going to travel up, but for the smaller stuff, it really works. Counterweight in this one was very, very simple. Out of some aluminum discs, double-sided tape, and bingo bango, we have the first incarnation. And this one worked really well. I was really, really, really happy with the tonality, the tracking, everything was good. So from there, I wanted to try something a bit more producible. By that point, I had realized it'd be really fun to share the idea and make it an open source project. The first incarnation, due to my hubris and lack of knowledge at that point of how exactly PLA would form into a bar, it produced a slightly flexible tone arm, and this didn't work. It was all super slick with internal channels for the wires and heat inserts and just lovely, but useless. So this guy, while quite aesthetically pleasing, for me anyways, didn't match up to the original wood hand-built version. From that point, I reverted to some of my building techniques from different projects in the past, and I had my printer working fairly well. So this is not the very first arm I built, but it incorporates 2 carbon fiber arrow shafts, 3 main pieces, the counterweight, the pivot, and the head shell holder. And they're similar to the original, whereas I glue a second piece on here to reduce vibrations and make it a bit stiffer with a lifter. The middle piece has the pivot separated by tape again in between here. And the counterweight is just a slide on with another piece of PLA on top to be another damper basically. And the design is mirrored in the bottom, so you have holes here, so you can adjust the azimuth if you have to add a bit of weight on either side. This one was very, very good, and this is still my main design that I'm going to keep for my turntables. I digressed a little bit along the way, and I made a knife edge style. So this one here I call the close shave, and it simply incorporates a one-sided razor blade into the design, and that pivots on a nice little brass trough inside the gimbal. And the gimbal, of course, you know, the new bearings out now, I mean, they'll just go forever. This isn't hard to do. I stayed away from a full gimbal design because I like the minimalist approach to the unit pivot. Less chatter, very easily adjustable and so forth. But anyways, just carry on here. So this one worked. It sounded nice, but at the moment it's on hold because I simply don't need it in my roster of tone arms. Then I wanted to go on to making something that was completely 3D printed. I designed this one for the Nebula turntable. This one worked really, really well. It sounded good, in spite of flexibility. I thought it'd be a lot worse. It wasn't. It sounded quite nice, but I realized that the stiffness really inherently improves the functionality of the tone arm. So there was a second one that followed right away. And inside you have an aluminum tube to hold the wires, and it also acts as a shield and a ground. Then it evolved to this guy right here. And this was the tone arm for the Nebula, and it still will be. I will have 2 options, or maybe 3 options for the Nebula turntable. And same as the one you just saw, except it has a truss design, so it made it stiffer. It definitely holds up better. But the same concept to go back to the first one. A little bit of mass for the cartridge, isolated pivot joint. And this one has an eccentric counterweight, so you can turn it for fine adjustment. And then you can slide it side to side for azimuth, so fully adjustable. And a little foam block to hold the aluminum tube, just like in the previous model, and it damps it very, very nicely. And from there, I decided to do a very simple tone arm. So my buddy Stu said, "Hey Andy, why don't you just try making, you know, one of his kind of concept designs?" And I gave it my own spin. I made 3 pieces, so you have the head shell, you have a pivot holder kind of thingy, and then you have a counterweight. It's basically as simple as you get. I call this one the S Cube for the super simple setup to get this guy going, and it sounds surprisingly good for the amount of parts in there. And the parts in this guy are simply carbon fiber tube, counterweight. It has a couple holes in it for weights that can be added. It has a very, very, very simple head shell. The angle is baked right in, so there's no need to adjust it afterwards. If you set it up with an 11, one of the 3600 cartridges, or one of the 2M series Ortophone cartridges, you'll be good to go with this guy. And of course, the little pivot holder. So these guys are the progression of the Tonearm, which was the first part of this, what became an ecosystem. As I kind of went through it, it got more and more interesting, because the first ones were just for the revolver turntable. But then by the point I got to the Carbo Extreme with the twin tubes, I had built my turntable. And this is where we're going to stop with this section. And then I'm going to set up the turntable examples and show you how that portion of it evolved. Thanks. I'll be right back. Okay guys, back. And here we go with the progression of the actual turntable. Once the Tonearm was working, I went, hey, let's just keep on with this experiment. Again, using only items I had in the studio. So what I did have was this mighty fine IKEA shelf. And I kind of went, that's kind of a cool little birch base. I had a few gimbal motors from different projects for cameras. I had an ESC, electronic speed controller, for it to use for testing servos. And I just incorporated the ballpoint pen pivot, taped the motor to the plinth, set it on 2 carbon fiber tubes filled with sand on hockey pucks. And that's how the little pucker name developed. Being Canadian, well, where else are you going to go with that one? So the little pucker was very, very simple. As you can see in the photos here, the first incarnations were rather basic and, shall we say, inelegant, but it worked. And that actually, frankly, surprised me. I didn't think it would actually sound any good. But the combination of materials produced a very, very nice sound. And with the longer Tonearm, it was actually a working turntable. Quite shocking, actually. So that was the very first incarnation of it. So we had our little birch wonder. And again, like with the Tonearm, my ego got the best of me and went, hey, I can make a really cool plinth for this thing. So I did. I made the original little pucker plinth. And I wanted something minimal, very basic. Functionally, it worked. A couple things, though. This material, you can start hearing the musical tone of it, which is quite nice, but the last thing you want in a turntable is that much resonance. Also, it wasn't totally stiff, quite strong, surprisingly, but not totally stiff. So a couple things were really working against it. Resonance, the motor goes right into the unit, too much vibrations. Even I made a special ISO plate for it and all these little adjustments. I still couldn't get it quiet enough for the rumble. There were a couple other factors involved in that. But so this guy, as sexy as it was and simple, had to be retired. Next up, I went, I think there is something I can do. I printed the next one hollow. And in these couple photos here, you can see the epoxy filling in one, the clear epoxy filling in one, and the other one I tried mixing with kitty litter, unused, of course. And all of a sudden, the thing's dead. Not only is it dead, it's really strong. So in this very sort of skeletal structure, we now had introduced a bit of technology that really did the job. The epoxy deadened it, strengthened it, and we had a workable plinth. So from there, it's like, we can carry on. I had already by that point developed the bearing, which is comprised of 2 ABEC 9 skateboard bearings. And again, all you folks out there screaming by this point, what is he doing? I've worked with different bearings, thrust bearings, angular bearings. If you're in a mountain bike and you weigh a couple 100 pounds and your handlebars are coming down your bearings, yeah, you need angular bearings. For a platter that weighs less than a kilo, not really. There's just no call for it. So they work just fine. And if you want to upgrade it, there's no problem. You could just stick in angular bearings as opposed to regular side load of an ABEC skateboard bearing. These things are like butter. They're incredibly smooth. 8mm shaft, and you're good to go. So the design is very, very simple for the basic workings of the plinth. The legs are just 2 parts that are taped on.
And I use tape throughout because the tape is used as an insulator. It'd be super easy to bolt it or glue it. The taping is intentional. It's not by accident. It's not for laziness. It's simply to make every joint a vibration attenuator. You don't want the thing to sing. You want a little bit of vibration in there, but you don't want the thing just humming along. So again, the legs get taped on, the carbon fiber tubes are filled with sand, slid in, and sits on a hockey pucks. And this is pretty much the final design that I'm going to go with for the little pucker. What I have in front of me is the latest incarnation. This one is on hold. I am having some issues with the motor on this one. It's not as stable as my Nebula turntable. And I will be including a video down below of the actual Nebula, which is, I would say, right on par with the little pucker in terms of success rate. It's incredibly stable for speed. It really works well. And what's really neat about these turntables is I went with an ultralight platter design. So the platter is actually just, again, skeletal with car weights on the edge. Yeah, they're car weights. They work really, really well to get a bit of peripheral weight for the turntable. So it's super light. It shouldn't theoretically work because the whole argument is you need mass to have the turntable working. Not really. This works exceptionally well when you have a motor that's matched to it. And the motor that's on the Nebula is a very good match. Internally, this one is the same. What I did was I made a very, very simple shaft that just fits in very accurately into the motor. And then you have on both of them 8 felt pads. I call this the felt clutch. And again, there'll be horror and screaming in the community. Why would he do that? Well, very simple. 2 reasons. Start up on these motors, there is a balance between torque and smoothness. And for the amount of torque I have to reduce, I didn't want to introduce a very complicated ramp-up algorithm. I might do it in the future, but for now I decided not to, and I'm glad I didn't because that's how this got developed. So it allows for a bit of slip on startup. The other advantage is it's an isolator. I'm literally putting the platter right on a motor, so you have to have something between them. And these felt pads do a great job. And again, the sort of what you call sort of the black level of the sound when there's no music is very, very good on these turntables. So they worked, and I'm very pleased to have that setup going. So that is the new setup for the Nebula turntables that we'll be carrying on in that way. For the little pucker, same goes for the platter. I fill it with epoxy, just like these guys, and I'll share a little snapshot, a little video here of how that's done. And it brings it up to, you can tune it, up close up to 1 kilo if you want. Depends on, I guess, your preferences in terms of, what it's going to sound like. I've switched to acrylic mats on all of them. They work really well in tandem with the epoxy filled PLA or the skeletal version. So you have a very, very nice balance here between lightweight, high performance, really good wow and flutter numbers, and sonically they're, again, I will provide examples. That's all they can do. And again, if a lot of people will go, well, the examples, I'm listening to it on YouTube. I'll provide the raw files as well. There will be a link where you can go listen to the uncompressed wave files and see what the tonality coming right off the turntables are. All the examples I'm giving are, there's no EQ, there's no processing, there's nothing on the actual sound of the turntable. I have all the full capabilities to do that if I wanted to, but I prefer not to because I like to do very pure input into my system, and then if my system is properly set up, it'll be a reference to what the original artist, producer, engineers wanted for us to hear. So this is a quick synopsis now of the second part of the ecosystem. So it started off with the tone arm. It moved to turntable design. So now I had a pretty sweet sounding rig, and playing it on my nice Paradigm system, I was quite happy with it. But I still wanted something that was a truly listening for pleasure environment. So that's the second part. I'm just going to set up here for a second, and we're going to move on to the last portion of the video, which is the whole amplification speaker system. All right, guys, I'm back. So after I got the basic sources done, I was on to the third and sort of final leg of the project.
I had read a lot about open baffle systems, and I actually had used open baffle setups in a pinch in live theater. We were in Dayton, Ohio, and we put 14 of them across the front of the stage. They were all EQ'd, time aligned, just set up properly, and they worked wonderfully. After that point, I had used them for small, very specific monitors where the director didn't want to see stage monitors, so I used a bit of plexi and a bit of reflection off some 4-inch coaxials back on the stage, just for the high frequency, so singers could get a bearing on their pitch. It wasn't designed for hi-fi or very good quality in that case. The one in Dayton did sound really good, but the second one was just as a pitch reference. So coming back to building open baffles, combining what I'd read recently, all the very, very positive reviews and some examples that were just lovely, I said, well, let's go open baffles. So once again, with the ethos of use what you have, I had a Celestion 7080 guitar speaker. I also had a couple Radio Shack 4-inch coaxials I used to use many years ago for practical speakers in plays, telephone rings. You just put them around the stage and they were great. And I went, okay, let's put this thing together. So I took this piece of plywood, which was actually the source for my very first platter for the very first little pucker, just lying around. I bolted the Celestion to here, and I can't remember how I affixed the Radio Shack speaker somewhere over here. Had a little crossover from a project I used to use to teach students about crossovers. And it sounded like ass. It was freaking horrible. It was just god awful. I kind of went, oh well, maybe this isn't really a project to kind of put too much time into. But deciding to veer towards the tenacious side of my personality, I persevered. So what I did was a couple things. I got the thing into an active system. I had a really nice old Denon audio-visual receiver with multi-channels, so I was able to start splitting things around in different ways, just using Logic, DAW and stuff like that to split up some frequencies. Very simple stuff. And as it went on, I found a couple of really cool programs. I found Ekio, and I found Banana. I'll put the links down below for those as well. They're really brilliant programs. So what you can do is you can reroute, if you're streaming, you can reroute the stream into the Ekio program, which is a crossover, EQ, and delay. Very, very, very professional setup. And there's a free version and one you can buy if you have more channels. And all of a sudden, it's like, hey, this thing's working. So the second incarnation, yes, fresh plywood. So this guy was the traditional open baffle setup. You got your baffle, you got a couple speakers in there, and it worked.
Called it off. As far as I'm concerned, the switch is numb to love. Oh, I'm giving up, I'm throwing in my hat. I can't take another lifeless little chat.
It worked pretty good. To my taste, my problem was I kept hearing the speaker. And with EQ, I could get some of those tonalities out, but I went, let's try something else. So in the next little series of pics and vids here, what I did was I suspended the whole contraption off a camera tripod. And all of a sudden, I'm there. This is what I'm looking for. I can work with this. Was it perfect? Oh God, no, not even close. But I could tell right away this was an environment I could work in. And the nature of dipole / open baffle / this whole concept is that you get the sound going in both directions. And after I did it, like just recently, I was reading some stuff. I almost peed myself laughing on this one. It was like, it's an audio short circuit. Well, I got demos working. It's not audio short circuit. You do have to work with the EQ a little bit, and you have to. It's not a gratis version of incredible sound. There's a lot of work. My version took about 6 months to tune to where I'm actually happy with it. I did go on to add a few things to it, but the suspended version was like, okay, we're there. We got something going. Then I moved on to my polecats. And these guys are the same elements that were in the suspended version, but this time I went over to IKEA. I got a couple table legs. I inverted them. Whoop, they're adjustable. And I had, again, some plywood left over for the bases. I mounted the speakers to the IKEA legs. I 3D printed some adapters for it. And all of a sudden I'm going like, we're getting really close to something usable here. At that point, I was starting to find the Denon a bit crunchy in terms of just the sound quality of it. It's a great product. Denon's a great company. It just wasn't what I was looking for. So I reached out to the great people over at Fozzy Audio, and it started off with a V3 stereo. I replaced the high frequency amp with the V3, and all of a sudden we're getting into like an actual refined level of sound quality. We're going, okay, this is now, we actually have a speaker that works. I can actually listen to this music and really enjoy it. Down the road, before I went further into the amp improvement, I got some speakers from Kicker, having worked with their stuff before. I went out and purchased a few of the, I don't know if you can see them very well here, but you'll see them in the other photo, 4-inch coaxial car speakers. And the car speaker, much like the other speakers that I used, were all designed for robust applications. Like the Celestion guitar speaker, a lot of guitar cabinets are open backed. The thing has to be more rigid. Now you can look at all the specs you want and do the analysis. I went the simple route. I know what it's made for. It worked. Same with the car speakers. They're made for more hostile environments. They can handle a lot. So going with that combination, the Kicker with the Celestion, I'm going, that's it. Speakers are done. Don't mess around with that for now. In the future, I might do some more experiments, but they will strictly be experiments. I'm actually happy with where the sound has ended up. The final step was these babies. I reached out to the great folks at Fozzy again and said, hey, you want to send me some of the monoblocks? And they did. And they are absolutely freaking awesome. So all of a sudden, the sound now had the V3 running the highs, 2 mono blocks with the 10 amp 48 volt power supplies, one for each one, tons of power and just refined, beautiful energy in the low end. The system was there. But I said, there's one more thing I want to try. I would just love to like round off that final edge with some like 3000 grade sandpaper. So I contacted Andrew Sparks, the Sparkles, and said, hey, would you like to collaborate on this project? I would love to have your op amps to insert into the system. And he very generously sent over a bunch of them, popped them in, and frankly, it's stunning. Like the improvement between the stock amplifiers and the op amps isn't like, you know, a transistor radio to like a Macintosh system or something like that. But it's there, and that there makes it finalized. It's like when you're mixing a song and you're doing your final compression for mastering, that small little bit of extra, that's what it is. And that extra makes it. So now the system truly evolved to a spot where I could say, I have an ecosystem. The ecosystem is an equilibrium, again, like I mentioned earlier, between all the parts. They all work together. They sound unified. So if I'm listening to vinyl, if I'm listening to streaming, if I'm listening to a CD, I get the same level of quality between all the mediums. I can run it up to 192.24, no problems with resolution. I mean, you know, if you down the road, if you want higher, you can just get a different, you know, DAC and you can bump it up. But since none of the music is often recorded anywhere higher than that, again, you're using the electron microscope to read the newspaper. You're looking for stuff that's not there. So you have to be sensible in terms of what you use for equipment and how much you want to apply in terms of money, resolution, and these type of things to your whole system to basically squeeze out the music from your whole system. This project will continue into next year. I will be working on tuning it, of course, refining it. I might try out some other systems if any manufacturers want to send stuff over to give a whirl and see how it integrates. They're very, very welcome to do so. I have a couple of people I'm already in contact with for subwoofers and so forth. So In January, there's going to be more cool stuff adding on here because the system goes down effectively. It kind of goes down to 40, to be realistic. There's a bit of a taper off, but it works. So you have a nice low end in it. It's not lacking in low end for jazz or vocals. If you're going into any kind of EDM or music that requires a bit more low end, it would be nice to have a sub. And that will be the January project. So there's a plug for you guys to come back and check out the new vids coming up in the new year. But in the meantime, I wanted to thank everybody who's been supporting my projects, all the vendors that have contributed equipment for this to happen. And again, please come back. I would love to have you here. Comments are welcome, of course. I'd like to have discussions. Let's keep it civil, of course. It's good to have an open discussion and share ideas. That's extremely welcome. And again, I thank everybody for watching this video. Y'all take care now and Merry Christmas.